Unit 9 is based on statistics, including mean, median, mode, range, interquartile range, outliers, and mean absolute deviation. There's a lot of new vocabulary in this unit we're going to be focusing on. You can see them on the screen here. And by the end of this video, we will teach you how to find all the different parts using this data set. We're going to start with talking about the extremes. You have the lower extreme and the upper extreme in a data set. The lower extreme is always the smallest number, and the upper extreme is the largest number. Now, you'll note in this specific example, the numbers are in order from least to greatest. You don't always get a data set that's already ordered. It is often helpful for nearly every single one of our items for you to have the data in order from least to greatest, specifically finding the lower extreme and the upper extreme. This is necessary when you go to find the range. Now, the range is the distance or the difference between the highest value and the lowest value in a data set. So you could say the upper extreme minus the lower extreme will equal your range. In this situation, by subtracting 65, the upper extreme, and 14, the lower extreme, you find the range is 51. I sometimes refer to the range as like a driving range or a shooting range, where the distance from where the target is to where you are is measured, and that's how you identify what the range is in a data set, is by subtracting the lowest from the highest. Now, the median is the middle number in a data set. And you can see in this specific situation, 4, 7, 9, 10, 13, 14, and 20, that 10 is the middle number. You can see the 3 numbers are before the 10, 3 numbers are after the 10. So when you've got an odd set of data, the middle number will be your median. Now, in this second set of data, there are 8 numbers. And you can see that the median actually comes between the 8 and the 9. There are 2 ways you can determine the median of a data set when there is an even number. One is you could just know what number comes between 8 and 9 just from your comfort with numbers. But another method that will always work is if you find the 2 middle numbers, you add them up, you can see 8 plus 9 is 17, and then divide it by 2. That will tell you your median. With median, you can only have one answer. So you can't say the median of this data is 8 and 9. It's got to be 8.5, which is the true middle of this data set. Now, quartile 1, which is one of the vocabulary terms you're unfamiliar with, is also known as the lower quartile. And with this data set, you can see the median's been found, which means that 3, 7, and 9 constitute the lower portion of this data set. And quartile 1 would be the middle of that lower half of the data. So you can find quartile 1 by identifying the middle of the lower half of your data. You'll notice that quartile 1 can be written with a capital Q and a subscript 1 if you want to save time. And that's important for a formula I'm going to show you in a moment. Quartile 3 is the same thing, but it's on the other side of the data set. So the middle number in the upper half of the data set would be quartile 3. So you can see the 16, is quartile 3. Now, the interquartile range is calculated just like when you found range of the whole data. The interquartile range is the difference between quartile 3 and quartile 1. So since quartile 3 is 16, quartile 1 is 7, you'd subtract 16 minus 7 to get 9. So your interquartile range, or your IQR, would equal 9. This is important when looking at a data set to identify the spread of the data. The interquartile range tells you how far apart the middle half of the data is. So you can see that although the range of all this data is 14, that the interquartile range is 9, which tells you the middle of the data is all within 9 units of each other. Now, you can use the interquartile range to prove outliers. In the past, we've looked at data and we've said, oh, that number's pretty far from the cluster, and that's how we identify the outlier. However, we have an actual mathematical way of determining if a number is an outlier, and that is by taking quartile 1 and subtracting 1.5 times the IQR. So in this case, the IQR is 9, and you would do 1.5 times 9, which is 13.5. You do 7 minus 13.5, and you'll see that gives you a negative number. Clearly, there's no values less than negative 6.5 here, so there's no outliers to the left of this data. This data is pretty well clustered. Now, you can do the same thing for the right side of the data, or the greater edge of the data, and you can do quartile 3 plus 1.5 times the IQR. So you can see 1.5 times 9 is 13.5. Add that to 16, and you'll see that any number 29.5 or higher would be an outlier. And again, our highest number is 17, so there's no outliers in this data. This data is relatively close together. Now, I think you remember from previous learning how to find the mean. The mean is an average of a data set, and it's the same average that your teachers generally use to calculate your scores. It's calculated by finding the sum of the data and then dividing it by the number of addends. In this case, you'd add 7, 10, 15, and 20 to get 52, and because there are 4 addends, you divide by 4 to find the mean of 13. You've done this many times before, and I don't need to spend a lot of time on it. However, this is an essential skill for finding averages because mean is often one of the best ways to identify one number to represent a set of data. But the main focus for us is using that mean to find the mean absolute deviation. Now, the mean absolute deviation is a new item, and we refer to it by the acronym MAD. And the mean absolute deviation is an average of how much data values differ from the mean. So in this same data set, we realized the mean was 13. So the difference between 7 and 13 is 6. This is 6 away from 13. This is only 3 away from 13. This is 2 away, and this is 7 away. So we're going to take those red numbers. These are each the deviation from the mean of these numbers. And we'll add those up and divide those by 4. So 18 is a total divided by 4 tells you the mean absolute deviation is 4.5. Now, much like the interquartile range, this tells us a little bit about the spread of our data. When you have a mean absolute deviation that's very small, it tells you that your data has a large cluster. Whereas if your mean absolute deviation is very large, it tells you the data is very spread out. The same thing goes with the interquartile range. With the interquartile range, if your data is very close together, then if your interquartile range is small, it means the center of your data is very clustered, and if it's large, it means your data is spread apart. Now let's go back to that initial question, which was to find the lower extreme, the upper extreme, the range median, quartile 1, quartile 3, the interquartile range, proof of the outliers, the mean, the mode, and the mean absolute deviation of this data set. Now the first thing we're going to do when we put this data set is it needs to be placed in order from least to greatest. 6, 7, 11, 14, 15, 18, and 20. So you can see our lower extreme is 6, and our upper extreme is 20. You may remember that to calculate the range, you subtract the upper extreme minus the lower extreme, which tells us the range is 14. Now to find the median of this data set, we need to find the middle. And you can see that there's 1, 2, 3, 4, 5, 6, 7 terms in this set. So the middle term would be 14. You can see there's 3 items to the left and 3 items to the right, so the median would be 14. Now, the lower half of this data set, you can find quartile 1 right here. And so this would be quartile 1 because it's the middle of the lower half of the data. And quartile 3 would be the 18 because it's the middle of the upper half of the data. You will also note that the median is also sometimes noted as quartile 2. We generally refer to it strictly as the median. Now, to find the interquartile range, just like we calculated the range by subtracting the largest and the smallest, we're going to subtract our quartile 3 minus quartile 1. Since 18 minus 7 is 11, the IQR is equal to 11. Now, to prove the outliers, we're going to use these formulas. Quartile 1 minus 1.5 times the interquartile range. Now, since our interquartile range is 11, we would multiply using our calculator 1.5 times 11, which we would find out is 16.5. And we're going to subtract that from quartile 1, which is 7. Again, we can subtract this all we want. We know it's going to be a negative number, and there's clearly no negative numbers here. I'm going to go ahead and type it in my calculator anyway and get an answer of a negative 11. I'm sorry, a negative, I want to make sure I get this right. So 7 minus 16.5 is going to give me a negative 9.5. Sorry about that. And I thought I had calculated that ahead of time. And clearly there's no numbers to the left of our data that are negative 9.5 or lower. So there's no outliers on the left-hand side of this data. Now we're going to do the same thing on the right-hand side of the data using the other formula. We're going to add 1.5 times the IQR. And you can see that 1.5 times 11 is still 16.5. And we'd now add that to the 18, giving us 34.5. And again, clearly, there's no data 34.5 or greater, so there's no outliers in this data set. And now we've proved that. We talked a lot this unit about justifying answers. We've talked about before, if your parents told you you couldn't go someplace, the first thing you'd ask them is why, because you want them to justify it. In mathematics, we need to justify much of what we do. Now, we're down to finding the mean. To find the mean, we're going to add up all of these terms. Now, when I add them all up, I get 91. I'm going to divide that by 7 because there are 7 terms, and I'll find the mean is 13. In the meantime, I'm also going to find the mode. Now, the mode we didn't talk about earlier because it is a previous learning. The mode is the number that appears most often in a data set. There was no number that appeared most often in this data set, so in this case, there would be no mode. You don't want to write 0 here because that would maybe indicate that there was more than one 0 in our data set when there's actually none. So we want to always write the phrase no mode if there's no mode. Now, because we know that the mean is 13, what we need to identify now is how far each of these numbers are from our mean of 13. So you can see the 6 is away from the mean by 7. The 7 is away from the mean by 6. The 11 is away from the mean by 2. The 14 is off by 1. The 15 is off by 2. The 18 is off by 5. And the 20 is off by 7. So what I'm going to do is add up those terms. 7 plus 6 plus 2 plus 1 plus 2 plus 5 plus 7, and then divide that sum by 7 because there were 7 terms. When I add all that up and divide it by 7, I'm going to come up with a mean absolute deviation of 4.3. And so my MAD, or mean absolute deviation, is 4.3. So I've shown you several examples of each type. I think that you should be comfortable with this and should do very well on your study guide and your tests. Thanks for sticking around till the end.